Hi. Today is Monday, February 15th, and I wanted to go over chapter 4, lesson 2 with you. I know this is the section that you guys put together presentations on, but it's hard to go forward without going through this section. So we'll still do the presentations, but I think there's a couple things from this section that would help moving forward, especially after I looked at your answers to the um, lab simulation that you guys did last week with the like the little check marks that you had to move around. Lesson 2 talks about the different forms of energy. So we learned that all of these different forms can be divided into some type of kinetic or some type of potential energy. But here they talk to you about um, those individual forms. And the goal of this section is to look at finding or calculating an object's mechanical energy, and then it just touches on the other forms of energy. So, mechanical energy, the groups that had mechanical energy, you saw that there were a few pages dedicated to this topic. And that's because in almost all situations, you're going to want to look for mechanical energy. And if you remember in class, we talked about it doesn't necessarily mean a machine. If something is doing work or applying some kind of force to cause a change in motion, then it would be considered mechanical. So the example that they give you here involves zero machines. You have a person shooting a basketball. The person is applying mechanical energy or using mechanical energy to shoot the ball, and then the ball does work or converts some of its energy mechanically into the net as it passes through. So if you have, one object coming into contact with another object, and remember, objects are made of atoms and molecules, so that could be wind, blowing on a sail or into a windmill, or a fan, blowing on a person and moving their hair. If you have matter contacting other matter in some way and doing work on it, then you have mechanical energy. So you might want to go back through and unsubmit the activity from last week, um, and check your answers on some of those drag and drops that you guys did. I'm showing you the teacher book on purpose in case you wanted to check the work if you had this section as part of your presentation. So it explains that mechanical energy and work. An object with mechanical energy can do work on another object. If you think of mechanical energy, like all forms of energy, as the ability to do work, like the ball falling through the hoop and hitting the net. The net moves as a result. So the ball touching the net as it falls through is considered mechanical energy. And then it turns it into kinetic, right? Because it makes the net move. The more mechanical energy an object has, the more work it can do. So to find an object's mechanical energy, you would add together the object's kinetic energy and the potential energy. So if you remember in our PHET activity, it not only used bar graphs, but it also used a pie chart. And the bar graphs you could see, remember they were connected. When one went up, one bar went up, the other one went down. So you always have some percentage of potential or kinetic in a given situation. And we generally associate the kinetic energy with motion and the potential with it being stored. It could be used, but it's not being used yet. So this is the video for mechanical energy. The next one will be about the other forms of energy. So make sure that you watch that one next.